I was in my bed and I was watching.
Focusing, like really, first hour was like, this was so hard. They really were saying this, and they usually don't say stuff like this. I feel like they usually struggle a little bit, but they were like, this year it's so much easier. And now seeing it again, because we've already seen this stuff, you know, it's getting easier and easier. Okay, so let's talk about this. An identity allows you to write something in a more simplified form, a better form. So it is always, guys, if possible, it is always better to have, instead of two terms, so our final answers we want, if possible, to not have two separated terms. It would always be better to have one term. Does that make sense? Now also, it is better to not have fractions. So anytime we can fix that, we would write the answer without a fraction. So if I had sine over u is equal to 1 over cosecant, what would be more simplified? Sine. Now that doesn't mean, so I have people say, well, so that doesn't mean that we're never going to take a sine of u and rewrite it as 1 over cosecant u. We might, but it's just if we get to a final answer and we see this, we would change it up. Does that make sense? All right, what's more simplified here? Cosine, right? What's more simplified here? Tangent. All right, good. So then we know these reciprocal ones. So yes, we do need to memorize these formulas, but we know all these ones. Now see, look, tangent of u, if you choose to use 1 over cotangent, and then a different person chooses to use sine over cosine, it doesn't matter. Not one person is more correct than the other. They are equivalent. They're both true trig identities. Your math in the end should simplify to be the same. So it just depends on the problem if you want to write it as cotangent or sine over cosine. So just a reminder that cotangent is cosine over sine. Yes. Yes, they are equal. So that's what I mean is like the math will work out eventually. It'll all come out the same because they are the same. So, very good. Next ones. You already have these written down. You don't need to be writing them down. You have them on the paper I gave you when you walked in the door, everybody, because I'm going to go too quick for you to write them down. You already have them down. So we have sine squared plus cosine squared equals 1. This one is really the easiest one for me to remember personally. Sine squared plus cosine squared equals 1. Now remember, there are the variations, meaning I could subtract cosine squared over, and if I saw 1 minus cosine squared, I would rewrite it as sine squared every time. It is better to have one term. Do you guys see? So then also I could take the sine squared plus cosine squared equals 1, and I could manipulate it by subtracting sine squared over. So if I saw 1 minus sine squared u, it would be more simplified to write it as cosine squared u. All good. Okay, cool. So which one's more simplified here? Obviously 1 is more simplified than sine squared plus cosine squared. Now you guys understand, like, these have to be squareds. So you can't just square root, and say, so then sine of u is equal to 1 minus cosine of u. Not true. We can't square root across subtraction signs, so that's not a true statement. They have to be squared. Okay, this is one I, even as myself, have to review it every year and rememorize it. 1 plus tangent squared is equal to secant squared u, and then we have our two variations there. Well, we have more than just two variations, technically, but... so if you were to see 1 plus tangent squared u, it would be better to write it as secant squared u, wouldn't it? Because there's only one term. And then you guys see the picture here, hopefully. Now you do have to pay attention to the minus signs, because if this was backwards, you'd have to take into consideration that and see if you could rewrite it appropriately. You already have those ones written down, and then we have 1 plus cotangent squared is equal to cosecant squared, and then our three variations. So you guys are all seeing now, hopefully, which ones are more simplified, right? The left, right here, the left side or the right side? Right here? Left is more simplified? Left, right? One term? Okay, cool. All right, now these ones are new to us. Now they're actually, you're going to see why they work. These ones I feel like are pretty easy to memorize. I really do, because once you kind of take a screenshot in your head of what's going on, then these are a little bit easier to memorize. So this tells us that if we have sine of pi halves minus some u, where u is an angle, so sine of pi halves minus u is equivalent to cosine of u. So if you were to ever see sine of pi halves minus u, it would be more simplified to write it as cosine of u, because obviously just cosine of just u is going to be more simplified than all this stuff inside. Does that make sense, everyone? So this side is more simplified. Now why does this work? Let me show you why these co-function identities work, everybody. Let's pick a u value and let's explore the math behind this real quick. So u is equal to, we can pick anything. Let's just pick something easy for easy subtraction and addition. So let's let u be pi halves. Are you okay with that? Yeah. Let's go see why this statement is true. Why we can switch these out, because they're equal. So let's see why. Let's plug in our u of pi halves. So that would be this. Sine of pi halves, and then u is pi halves. so minus pi halves, and we're told should we come out to be equal to cosine at pi halves. Isn't that what this true statement says? Well, then that says that sine of 0 will be equivalent to cosine at pi halves. Well, let's calculate that and see if that really works. The sine at 0, here's 0. The sine at 0 is 0. Now it says find the cosine at pi halves. Here's pi halves. The cosine at pi halves is 0. So do you guys see how they're equivalent? So we can literally switch them out. If you see this, you can write it as this. So notice sine goes with cosine. Then cosine goes with sine. Tangent goes with cotangent. Cotangent goes with tangent. Secant, look, if sine and cosine go together, then it would make sense that secant and cosecant go together, right? And then cosecant and secant. So it would obviously be more simplified ever if you were to see the two terms inside. It would be better to write it as one term. So for the most part, I feel like those are pretty easy to memorize, besides not forgetting that, like, see how tangent and cotangent are reciprocals. These aren't reciprocals, so, but we just kind of explored why, hopefully, like mathematically why this works. All right, and then our last one we're going to learn today is the even and odd identities, which we've already learned before, so just a reminder. Sine is considered an odd function, so that means if we take and plug in a negative u, it'll always simplify to be -1 times the original function, so that'd be -1 times sine of u. So fun fact for you, just so you know, it is more simplified to have a negative on the outside than inside. It would be better to write this as this. It is just better to not have a negative inside your parentheses. So sine of negative u is equivalent to negative sine of u, and we would prefer this. So if that's true, then the reciprocal for sine is also odd. So cosecant of negative u would be better written as negative cosecant of u. Now cosine's an even function. That means if we plug in a negative, we get out the original function. So this would be more simplified written as just cosine of u. Well, if cosine's even, then secant is also even. So that would be more simplified as that. Tangent is odd. So sine and tangent are odd. So tangent of negative u is equivalent to negative tangent of u. Same with cotangent. So you have all those written down. So yes, I mean, a little bit of memorization, but a lot of it is kind of intuitive. So start trying to memorize them. Now, those ones. Those are the only ones we're focusing on for this lesson. So you'll want to bring that Trig Identities page for the whole unit. All right, so it says, now we're just going to do examples and see how this works. It says use the values given that secant of u is equal to -3/2 and your tangent of u will be greater than 0 to find the values of all 6 trig functions. Now everybody, we are given secant of u is equal to -3/2. That is not a unit circle thing, is it? No. So it's a right triangle. So what I would do is I would draw in like a quadrant 1, 2, 3, and 4, and I would just draw in a bunch of right triangles here. Because we don't really know, well we do know, but we're going to have to figure out which quadrant is our triangle actually in real life. Now it's u, so our angle's being called a u in this one. We put angles by the origin, don't we? Now we're told that secant, I would rather use cosine, so I'm going to go ahead and reciprocate it. Another true statement is cosine of u is equal to -2/3. Agreed? So we're given that the cosine of u is equal to adjacent over hypotenuse. So now our hypotenuse is always positive, just a reminder. So 3, 3, 3, 3. Now we're told our adjacent side is -2. Now if our adjacent side right here, wouldn't it be positive? The positive x-axis. So that wouldn't be it. It would not be either of these. We can cross those out. Our adjacent side from our u's are negative. So now we know it's between either this or this. Does that make sense? All right, cool. So now we would do Pythagorean theorem to find our other side. So let's do that. So you would do 3 squared minus -2 squared equals the other side squared. So then that's 9 minus 4 equals question mark squared. 5 is equal to question mark squared. So the square root of 5 is the other side length. Now if we put it here or here, this is going to be negative. This is going to be positive, isn't it? Now we're told right here, your tangent will be greater than 0. Doesn't that mean it'll be positive? So tangent is opposite divided by adjacent. Let's do opposite divided by adjacent here. Opposite divided by adjacent would be -√5 over -2, which is √5 over 2. Is it positive? Yeah. What if you were to do this one? Opposite over adjacent, wouldn't it be negative? So it would be less than 0. So this is not the triangle. It must be this one. So now you would just answer your 6 trig identities. Sine is, oh heck, cosine is adjacent over hypotenuse, tangent is opposite over adjacent, and then you'd reciprocate them. Does that kind of make sense? Okay. I'm not going to finish writing those out because I think the hardest part is figuring out which quadrant we're drawing this in. So just draw it in all 4 and then fill in the ideas. Okay, let's start simplifying. Honestly, these are fun. Now guys, once again, there is not a right or wrong way to do these. There's right ways and then there's long ways. Like, if you say a true trig identity, then it's not wrong. Now here's the thing. As we get better, hopefully we'll choose smarter options in simplifying these. So here's a few things to know. I'm going to give you a few hints based on what we see. So if you're ever given something that says that has 2 terms, often if there's something in common, it's a good idea to factor that out. It might not help you, but it might. Does everybody see what I'm saying? So look, we have 2 terms in this one. It might be a good idea to factor out the greatest common factor. So let's factor out a. Okay, so let's pull out sine of x, and let's see what's left over. So divide by sine of x, divide by sine of x, and let's write what's left. Cosine squared of x minus 1. All right, now from here, you would say, I would rather write this with just 1 term. If possible, which is definitely possible, right? So what trig identity are we going to use here? Sine squared x plus cosine squared x equals 1, true? Yeah. Now it needs to be cosine squared x minus 1 in that order. Order matters, guys. So wouldn't I subtract 1 this way? Yeah. So then I would also have to subtract sine squared this way, wouldn't I? So then we have cosine squared x minus 1 equals negative sine squared x. So wouldn't it be better to write it at least as negative sine squared x, because then I only have 1 term? So I'd rewrite, this is what I need to see, because notice we aren't given the answer anymore. We have to be able to know when to stop. So I have sine of x times by negative sine squared x. What is that? That's a times sign, not a subtraction sign. So what is that? Yep, negative sine cubed x. Now look, there's only 1 term, and there's no fractions. That is as good as it gets, guys. Right there. Look at that compared to the original. It is more simplified. Make sense? Okay, next one. All right. There was another way to do that one, but like I said, there's lots of different ways. Okay, so this one says simplify the trig expression. So once again, anybody have any ideas of where they personally would start? It might not be the same as someone else. So you're saying that you're seeing a cosine squared x inside our parentheses? Okay, so this is how you show your work for me, nice and pretty. So you would say, okay, that's equivalent to secant squared x, and then you're saying that that's times by cosine squared x? Yeah. Right, okay? You don't get to do it in your head, right? So I need you to tell me what you do next.
Secant squared x is equal to 1 over cosine squared x.
Good, so we have 1 over cosine squared x times cosine squared x, which is? 1. Okay, good. Because cosine squared over cosine squared is 1. Perfect. That would be the perfect amount of work that would need to be shown for an exam. Now, obviously, 1 is much more simplified than this stuff. The point of this, guys, is if in the future, when you take calculus, you might be asked to do some calculus on this function right here, or on this expression. Well, if you can see that it's equal to 1, calculus on 1 is a heck of a lot easier than trying to do it on this stuff. All right. All right, 34. This is just out of the book. I just thought maybe some of you might want to know which problems I'm doing out of the book. Even though I only assign you odds, I get that. But all right, so any thoughts on how you personally would start this one? So, okay, so you said that is, so we have 1 over, okay, secant squared x. Now I've had people always stop, like, here. Well, that's not the prettiest answer. So, cosine squared x, isn't that as pretty as it gets? You have one term and no fractions. There's nothing better here. That is perfect. Okay, good. Way to think. Another one. Okay? Lots of different ways to tackle it. Anyone? What they would do, because remember there's not a wrong answer. What? Okay, so somebody says they would do tangent squared is sine squared theta over cosine squared theta.
Yeah.
True. Divided by.
Secant is 1 over cosine squared theta.
So you would write all of these with.
Multiplying fractions would be just pi over the second multiply.
Okay, so you would flip that and you get cosine squared theta over 1.
Yeah, sine squared theta.
Perfect. One term, no fractions. Beautiful. All right. Now everybody, let me point out here. It says, find the cotangent of pi halves minus x times cosine of x. If you recognize, oh, pi halves minus x was an identity. Now remember, didn't we say that cotangent and tangent go together on this one? So a better way to write that is literally just tangent of x. So we have tangent of x times cosine of x. So you're showing your work.
And then it would be tangent is sine over cosine. And then multiplied by cosine to
Sine of x. Very good. Awesome. You guys are doing great. All right.
Oh wait, it's just cosine t, and I was like, cos. Cosine, so 1 plus tangent squared equals secant squared plus t.
So you're saying that is
Secant squared.
secant squared t, okay? So you're saying that we have cosine of t times 1 over.
Oh, and then it would be 1 over cosine sine, and then that would be secant.
Yep. See, I don't know why anyone wouldn't like identities. Like, that's fun. Okay. All right. So let's look at one more. Another one. Keep going. There's a reason I'm doing some of these. So I heard somebody say they would change cosecant to 1 over sine, okay? So we have 1 over sine of phi times by sine of phi over cosine of phi.
And then it would be 1 over cosine.
You're changing that to 1 over cosine? Okay, 1 over cosine of phi, okay? Okay, 1 over cosine of phi. Okay, what would you do next? I changed the theta, doesn't matter. Okay, what? Yes, but don't skip there. Tell me what you did. Yes. So guys, this is secant theta plus secant theta.
Oh wait, right.
So that's 2 secant thetas. One term, no fractions is better than 2 terms up there. Okay, cool. A lot of you were saying that. I just wanted to show the work for the video. Okay, now everybody, look at the instructions here. It literally just says factor the expression. This is getting us to the point to where if you were to see this in the future and it might be useful to factor it, that you could. So, factoring the expression. Let's do a u substitution. Doesn't it look quadratic? Let u be secant of theta. Well, if that's true, then wouldn't this be u squared minus 1? Well, multiplies to be negative 1 and adds up to be 0. 1 times negative 1. I can quick factor, so this factors to be u plus 1, u minus 1. Well, u's not u. U is? So it's actually secant theta plus 1 times secant theta minus 1. It did say factor, so we're done. So what that is doing is in the future, what if you were to see this problem? Now remember, there are different ways to tackle it. It's not that this would be the only right way to tackle this one. So what if you saw this problem? This is just helping you get to the point where you could see, well, I could factor the top, and then things would divide out. Does that make sense? There are other ways to tackle this problem, but it's just another way of thinking about it. All right, we're done though. It did say factor. We've done that. Okay, let's factor this next one. Now it says, looking at this, what kind of factoring? Well, isn't it quadratic in form? So our u substitution must be Tangent of theta, right? So then you have 4u squared plus u minus 3. Being very careful to notice that we're going to have to long factor. What multiplies to be a times c and adds up to be b. And then we have to drop and break, right? I'm not going to go over how to factor because let's hope we know how to factor still. Factoring by grouping now at this point, pulling out a 4u. Left is u plus 1, right? Pulling out a negative 3, left is u plus 1. Have I done it right? Safe haven's the same, so I pull out u plus 1 and left is 4u minus 3, but u is not u is. So we're factored when we put in our tangent. Tangent of theta plus 1 times by 4 tangent of theta minus 3. We've just factored it. There's your answer. So you'll be done at that point because it is factored. And somebody asked me last hour, so we're not solving? No, it did say factor. Done. Stop at your factoring. Okay. Now look at the problem in this one. It says factor the expression. We've run into the problem that we have a cosecant squared minus cotangent minus 3. If it was cosecant squared minus cosecant minus 3, it would just be a u substitution, right? So the problem is we have two different not identities, but trig functions here, right? We have two different trig functions. They need to be the same. So here's what you're going to do. You've got to figure out a way to write cotangent with cosecants or cosecants instead as a cotangent. We need all cotangents or all cosecants. Any ideas? Now remember, identities are equivalent true statements. Yes?
Isn't that 1 plus cotangent squared cosecant?
Yes, you're awesome. So you're saying that is equivalent to what? Well, would that be helpful? Yeah, because now don't we have a true statement with only cotangents in it? So now we have minus cotangent of x minus 3. Then you'd say, let's get this bad boy in standard form and let's combine like terms. So that's cotangent squared x minus cotangent of x, right? And then minus 2. Now I had someone last hour ask me, can I combine those two? But that's like combining an x squared plus x or x squared minus x, right? We can't combine those. So now we'll just do our u substitution. U is equal to cotangent of x. So then we have u squared minus u minus 2. It multiplies to be negative 2. Adds up to be negative 1. 1 times 2, negative 2. Quick factors to be u plus 1, u minus 2. Therefore, it factors to be cotangent of x times by cotangent of x. Cotangent of x plus 1 times by cotangent of x minus 2. All right, so if you ever asked to factor and you don't have the same trig function, you got to manipulate it with your trig identities so that they all are the same trig function. All right, we're doing really good here. Okay, so there's a couple that I feel like this might be the one that you're going to see. I don't know. Let's just go with it. What would you do? Not a right or wrong answer here. Okay, so I like that idea. So you would say that you're saying that we have a sine of, let's change to x. Anyone mad about that? Sine of x plus, and then you said cotangent is cosine of x over sine of x, and then times by cosine of x. That is true. So what do we have now? So we have sine of x plus cosine squared of x over sine of x. What would you do next if it was you? You would what? Oh, that's interesting. I've never heard that one before. You said you would change this to be what? Yeah, that's one way of doing it.
Or you could take the denominator and make them the same like
Yep, or get a common denominator. Both equally correct. And I bet both would simplify pretty quickly. I'm going to do that one. Isn't it better to have one term, everybody? Yeah. Then let's put this together. Let's make it so that there's one term. So wouldn't I times by sine of x over sine of x? Yeah. All right, so then right here now I have this. Sine squared x, don't I? Plus cosine squared x all over sine of x. So that'd be 1 over sine of x, cosecant x. And I bet So if we would have changed this to 1 minus sine squared x, that would have worked out the same answer. That would have been great. Because look, guys, if we would have done that, I like it. Let me write it down. So we have sine squared x, and then we have plus, and then you said this is 1 minus sine squared x all over sine of x. Now look, we're going to get the same answer, because can I split apart a numerator? We just can't split apart denominators. So now look what I have. Sine of x plus 1 over sine of x minus sine of x, right? And then look, these cancel out. Cosecant. So you guys see, it really is true that as long as you don't break any mathematical rules or trig identities, whatever you use should end up at the right answer. Cool. Okay. Another one. I think this was the one. I'm not going to say. Let's just go for it. All right. I just can't remember now. There's so many examples. Okay. Still doing good on time, but stick with me for a second. Simplify the expression. So here's the thing, guys. With this one, notice there's really not a better way to write this, because if you were, a lot of people say, well, cosine over sine is better as cotangent, because that's only one. That's only one term, I mean, not a fraction. But then you're like, well, yeah, but it's still the worst to have two terms. So if possible, we need to put these two terms together. So we would then rewrite it as cosine over sine, because don't we need a common denominator? So let's write what we have here. So if we are going to try to put this together, we would need our common denominator. So when I multiply this by 1 plus cosine of theta, so 1 plus cosine of theta, and then this one I multiply by sine of theta over sine of theta. So now let's look what's in our numerator. We did all this so we can combine the numerator. So then we have sine squared theta. Sine squared theta from that. Then we have a plus. I would distribute cosine theta plus cosine squared theta. And that's all over sine of theta. Good. Now, would it be appropriate to divide across addition signs? Don't be tempted. Don't do that. Do not do that. You can only divide across multiplication signs. And, like, that's all added. Okay, any ideas? Awesome and beautiful. Isn't that equivalent to 1, she's saying? You nailed it. So you're saying on top we could rewrite that as 1 plus cosine of theta.
And then they both cancel out.
Good. And so then I have on bottom sine of theta times 1 plus cosine of theta. Now I had someone once again last hour say, but Ms. Christensen, that's dividing across addition signs. Well, it's the entire factor, so it's fine. Does everyone see? Yeah. So yeah, now they do divide out. So our final answer, good, our final answer is cosecant theta. Awesome. Okay, so everybody listen to this. This is usually where people get stuck. This is the one you really need to listen to, because really, a lot of people get here and they're like, I literally have not one thing I can do here. So let me just explain something. So we have 1 over 1 plus sine of x. If you ever have a 1 plus and then a trig function and it's not squared, because if it's squared, can't we write it as something else? If you ever have this happen, always multiply by the conjugate and it will usually help you out. If you have two terms, and one of them is a 1, and the other one's a trig function that's not squared, multiply by the conjugate. So what would be the conjugate? 1 minus sine of x. So that's a trick you're going to have to just remember. 1 minus sine of x. So now on top, I get, now because look, we're not changing the problem, we times by a 1 of our choice. So on top, we get 1 minus sine of x. Now let's see what we get on bottom. 1 times 1 is 1. Now middle terms cancel out, minus sine x plus sine x, and then we get minus sine squared x. Good, so we have 1 minus sine of x divided by cosine squared x. So some of you are feeling like you want to split it up. Let's roll with it and see what happens. Okay, so what would you do next? Secant squared x.
Oh wait, no, because they're both not squared.
question is, so we have sine of x divided by cosine x, true? So sine over cosine is tangent of x divided by cosine though, right? So then couldn't I bring this up to make it secant? Well, let's look back to here. What could I have done? What could I factor out here? A secant. So look, do you guys see how now we're gonna, like literally if we kept going, like we're gonna undo what we just did. So like, the best answer is no fractions. So what I would do is start here. And isn't this, can't I bring it up and make it secant squared x on top? So I have this, secant squared x on top, times by 1 minus sine of x. And there was nothing we could do to make this have one term. There are times when that will happen. If you try to keep going, you're going to start seeing yourself undoing. You're going to get back to this step or something. You know what I mean? It's going to undo it if you just keep going. So you do have to know when to stop. So there are times when you've gone as far as possible. There's nothing you can do to put those together and make them one term. So I guess it is above all, like, so, because it's like, well, who's to say that, like, right here's one term, right? And here is two terms, but no fractions. So I guess, in my opinion, in the opinion of what would be considered more simplified, I think above all else, they prefer no fractions. So even though, so this one was like, it has to be fractions or it has to be two terms. There's no other choice. Go with the two terms. No fractions. Okay, cool. All right, I was glad we did that one because I always have people think that every time you can get them together and you can't every time. Okay, let's read this problem here. We're actually almost done with the lesson here. It says, use substitution for x equals 2 tangent of theta, where theta is between 0 and pi halves, to write the square root of 4 plus x squared as a trig function of theta. So it literally tells us, use substitution to write this instead as a function of theta. Now we're also told our theta is going to be between 0 and pi halves. So now think about it, theta is going to be in quadrant 1. Won't all trig functions be positive in quadrant 1? Okay, so. Alright, so let's go ahead. We don't have to worry about any negatives then. So now what do you think we're going to do based on what it says? Substitute that in. Doesn't it even say the word substitute? So you have the square root of 4 plus, instead of an x, we have 2 tangent of theta, and now it's squared, right? Now it is not breaking a forbidden rule. If that's a times sign, it's not breaking a forbidden rule to square that. In fact, it's necessary. So we have a square root of 4 plus 4 tangent squared theta, don't we? Now I can't just square root that, because that's across an addition sign. However, can I factor something out? So I'm going to pull out a 4, divide by 4, divide by 4. So then left is 1 plus tangent squared theta. Good. So you're saying this is 4 times secant squared theta? Yes? Well, now this is a time sign. Can't I just square root each of these if it's a time sign? As long as it's not an addition sign, it's okay, right? So the square root of 4 is the square root of secant squared. So 2 secant theta would be our final answer. Okay, I really like that you asked that. I've never had anyone ask me that. So plus or minus technically could be there if we weren't told that we only want the positive from quadrant 1. Good question. And just a reminder, usually when simplifying, we don't do plus or minuses, only when solving and we actually take a square root. But that was I'm glad you asked that. Last example of the day. Now, oh my, I'm praying that you guys can make me not cry like first hour. Okay, guys, it says, take these 2 logarithms and instead write them as one single logarithm, and then after that, then simplify. Please tell me that some of you remember your properties of logarithm rules. Anyone want to tell me how to write this as one logarithm? Yes. Thank you. Thank you. You're saying when you add, you multiply. Yeah, that's the rule. When you subtract, you divide. If you have a 2 in front, that's an exponent, right? Those are the 3 rules. So this is an equivalent statement. ln of cosecant theta times tangent of theta. Now I've written it as one logarithm. So now it says then simplify. So that's ln of 1 over sine, isn't it? Times sine over cosine. So then you get ln of 1 over cosine. So we have ln of secant theta. ln of secant of theta. Just please remember your logarithm properties. It's not when you add, you add. It's when you add, you multiply. When you subtract, you divide. Any powers in front, anything multiplied in front is just an exponent on whatever's in here. Okay, cool. That's the end of the lesson. The rest of the time is yours. You have 40 minutes.